Hey guys, Buildzoid here, and so I had a random idea for something I'd like to test with the Ryzen 5 7600X, which is I wonder what the maximum frequency of each of the individual cores on this chip is for Cinebench. So we're gonna try test that, because you can set the frequency of the cores individually in Windows, and it's not super like difficult to test this. So yeah, also I'll move the mouse over to a desk so I don't shake the camera. Anyway, um, yeah, so we're gonna have now the thing is the per core overclocking on Ryzen has some like weird frequency relationships. So yeah, you'll see like technically I have all the other cores set to like 1 GHz, but I think there's like a divider where it's like this core is at 2300 and then the others are at like half that. So I wonder what happens if we go to like 4 GHz. Yeah, so there seems to be some kind of like ratio of the core to core frequencies. I'm not sure what the ratio is, but yeah, that's fine. Um, so we're currently at 1.3 volts, and I'm pretty sure at 1.3 volts we should be able to do 5.6 gigahertz, at least on one core. So that's what we're going to test, which does pull up our other cores to 2.2, but that is still low enough that we shouldn't have particularly high thermals. And for testing, I'm just going to use single core Cinebench because it's a nice, easy single core test to run. Like, it's a lot faster than one of the modern Cinebenches, because modern Cinebench just takes forever. Um, which is kind of the point if you have a very fast CPU, but if you're only running one core, um, yeah, that's not really like there's no benefit to running the test a single core test longer. Kind of wonder how the temperatures are doing. I wonder if the workload is also skipping from core to core. Yeah, it looks like it is, which is not ideal. I'm gonna run it on CPU 0. I really There we go. Now we're seeing, yeah, it's sitting at like 50C. It also seems to be running a bit faster now. There's no reason that we have to wait for it to finish. We can just keep clocking it up as it's running. Wonder if it'll do 5.7 at 1.3 volts. The temperature's certainly low enough, I think. Well, it didn't crash instantly. 575? Oh, still working. Still working. Okay, what about 5.8? Because I'm kind of wondering, like, can you clock individual cores, like, to, like, 6 gigahertz? Like, can each core individually hit, like, 6 gigahertz? But when you try to load all of them up, your thermals obviously go totally out of control, and it doesn't work. Okay, so it looks like 5.8 at 1.3 volts. It's not stable. So I guess we'll bump it up to like 1.35. So I guess we're not going to see 6 gigahertz on each individual core. Unless like there's a really big gap in silicon quality between the cores on this chip, which there might be. So I kind of wish I had more pixels to work with, so this is going to be more difficult to see for you guys, but less annoying for me to navigate. There we go. I guess I could have also... Nah, single-threaded Y cruncher would have been like a pain to set up. I do want hardware info, and where's my Ryzen master? Okay, it still remembers the settings that we had before, yeah, so we crashed at 5.8, so I'm going to bump it up to like 1.3... Let's say 1.325. And where's hardware info? I think Cinebench might have been reset. So I'm actually gonna set it to 1, close it so that it remembers the setting, and then... oh, wait, which means I need to redo the affinity now. There we go, and run. It's 5.8 on one core and everything else at 2-ish. Yeah, so 5850 does not work. That just instantly crashes. So I'm surprised that's not as much of a, like, frequency gap. Well, okay. Yeah, it's not really that much of a frequency gap going from, like, all-core overclocking to single-core. Right? Because, like, all-core, this chip maxes out at, like, 5.57. Oh, I didn't want to actually go into the BIOS. Yeah, it maxes out at, like, 5.57. If you clock all the cores at the same time. And admittedly, we aren't, like, mashing a bunch of extra voltage into our one core that we're trying to push to 5.8. But, like, yeah, it's not a big improvement. And I guess that kind of makes sense, but... Because, so 5.8 over 5.57, that's like... It's like a 4% difference in clock speed. It's not a very big improvement. Even though we're just running it on one core instead of all of them. Where's hardware info? Oh, and I do need Task Manager again. So actually, I kind of wonder if we can even get that one core to 6 gigahertz. So I'm just gonna go 1-2 skip a few on this, and we're just gonna go straight to like 1.4 volts. Hopefully it doesn't roll over, but it probably will. And we're gonna start with 5.8 because if it did roll over, then 5.8 might not be stable anymore. I did the affinity right. Yeah, the affinity's set. So here we go. Run. Yeah, and we're seeing like 10, man, it's like 10 degrees hotter now with the extra voltage. Which isn't too surprising. Because, like, that is quite a lot of extra voltage, the 1.4 volts. And we are actually getting, like, almost all 1.4 volts, because, like, with the very low current draw that we're seeing, there's not a lot of V-droop. Let's try 5850. Okay, that now works. What about 58? Let's try 5900. And no. Okay. Yeah, so I don't think, like, I'm not going to give it more voltage at this point. Because on the stock boost system, the CPU will actually boost to quite high voltages, like over 1.4 volts, but like it's not gonna. Well, okay, actually, we're gonna try it, but I don't think it's gonna hit 6 gigahertz even if we shove like 1.45 volts into it, and I'm not going above that. I have very little faith in that being good for the health of the CPU. I mean, even 1.45 volts I think is awfully high, but for a Ryzen chip. On an Intel chip, I wouldn't be too worried about it, but this is not an Intel chip, so let's Go up to 1.45. And again, we need to check that 5.85 doesn't crash at 1.45 because it could have rolled over at this point. I mean, it can roll over at any moment, so we can't just like raise the voltage and the frequency. We need to raise the voltage, check that it hasn't made stability worse, and then we can start working on the frequency. Yeah, now we're seeing 60C on that core. I have a sneaking suspicion it's not gonna... Yeah, it's over 60. I don't think it's gonna be particularly thrilled about this. Yeah, no, we've hit the limit. Like, it ain't scaling past this point. It's interesting how it just completely oh, I guess since I'm crashing the first core, I guess I'm taking the OS out with it. So maybe once we start hitting, like now that we start working on the other cores, it won't be taking down the entire operating system every time it crashes, which would be nice. But yeah, I'm not sure if that's actually gonna work out that way. But that would be nice if crashing the other cores didn't take Windows down with it, but so now we're going to start working on core 3? No, core 2. Yeah, because as far as I know, the way the Windows core labels work is like you have core 0, hyperthread 0, core 2, core 1, hyperthread 1, right? So we want core 2. I mean core 1, because cores are counted from 0, right? You have core 0, 1, 2, 3, 4, 5. Anyway, so 1.45 volts evidently doesn't really do anything for us, so we're going to go back down to 1.4, and we're going to drop this all the way down to 1 gigahertz, and we're going to pull this all the way to 5.6, or like 5.65. Yeah, we're getting 50-ish C, 5.65. Try 5.7. Works. 5.725 also works. 5.8. Ah. So evidently, yeah, so it looks like the little star label in Ryzen Master is probably pretty accurate because this core can't even do 5.8 at a voltage that the better core could do. Oh, I keep autopiloting into the BIOS. Sorry about that. Kind of want to note this down, but, well, it's actually not that useful, because the thing is, you can't, like, you saw what it does to the, you saw what it does to the frequency on all the other cores. Like, you can't have, like, 50 megahertz differences between different cores in terms of frequency. They all have to be, like, there's a pretty big gap. So you couldn't, even if you tested each individual core and it was like, you have one core that does, like, 585 and another core that, or, like, one core that does... Because if you were actually doing all-core overclocking instead of, like, this per-core thing, you wouldn't be able to reach the, like, single-core frequencies that we're seeing right now. But let's say you were at, like, 1.3 volts, and you wanted to have, like, 5.6, and then 5.57, and, or, well, 5.6, 5.5, yeah, 5.57, then, like, a 5.55, and then maybe another 5.57, and maybe another core does do 5.6. Like, if you wanted to do something like that, you couldn't, because the cores can't have such a small frequency gap between them, which is, like... And you might say, oh, that really sucks, but then consider the fact that 25 megahertz at, like, over 5 gigahertz is, like, not even a 1% difference. It's, like, half a percentage point, so it wouldn't really significantly affect performance anyway. Like, going out and manually tuning each of your cores by 25 megahertz is, like... not gonna really achieve anything in terms of performance. But I was just kind of wondering, like, what kind of frequencies we can hit on individual cores. In an actual workload, obviously, if we were just idling the cores, then we could probably do a 6 gigahertz pretty easily. I don't see a reason. Let's try CPU 4 at this point. Because I don't see a reason to keep continuing on a core that just failed. Game mode. So yeah, we're going to drop down. We're going to do core 3. I think that's the right one, right? So core 2 now says, yeah, 40. Yeah, so that is the right one. Oh, we're going to go straight for like 5.7. And run our workload. Check our temps. Core 2 is hitting, yeah, 50C. So let's see if we can do 575. We can, at least like it's not immediately crashing. Can we do 5.8? No. So that's a pretty big gap in the frequencies for the cores. Like, I want to quickly recheck core 0 because, like, core 0 was doing like 5850, and I think that was even at 1.4 volts because it like didn't scale to more than that. So we're gonna quickly check core 0 for 5850. Oh, and I guess I should apply that after I have everything set up so that it doesn't just... No, just affinity, 0, okay. And then apply, and we've got our 5850, and we run. And yeah, core 0 can actually do like 5850. So that's a pretty big gap between like the cores in terms of max frequency, right? Because we've got like C2, C3, like neither of those does 5800 even. So they're like 75 or 100 megahertz worse at the same voltage. Anyway, we're going to drop that back down. So now we're going to try core 4. Going to try, again, we're going to start with 5700. And I guess this little symbol is the... Oh, that's the second fastest. I thought that was like a potato core. That would have actually probably been a more helpful indicator, is like, hey, this core really sucks from an overclocking perspective. But anyway, affinity. So now we're going to be on core 6, right? Yeah, which is core 3. And 57 works, and we're hitting about 55C. It's kind of interesting, is like we're not seeing like huge temperature differences in the cores right now. When we're like running them one at a time, like they're all hitting pretty similar temperatures. Which is not what I expected. I thought we would see like some pretty drastic differences because some of the cores on this chip run like significantly hotter than others, but anyway, let's try 5750. Okay, that still works. I'm running that on the core 3 and core 3. Yeah, so I do have everything correct. 5775. Okay. 5800. Oh, we have another core that doesn't crash at 5800. That's impressive. 5825. And it doesn't do that. So I guess the second best core is going to do 5825. All right, because otherwise you'd expect... well, this one does 5800. The best core does 5850. Well, maybe the second best core also does 5850. And maybe if the sorting process at the factory isn't that sensitive, then we might even find that the second best core is actually slightly better than the best core according to Ryzen Master, but I kind of doubt that. Like, so far, well, we'll see. We'll see. I've not actually ever done this test on any other Ryzen chip before, so I really don't know what to expect in terms of results. This really was just sort of an idea I had earlier today of like, I wonder if any of the cores on this chip can do 6 gigahertz like at all in an actual workload. Because like I'm sure we could get a screenshot of 6 gigahertz, but that's pointless in my opinion. It's just like if you can like a frequency you can achieve when the CPU isn't actually doing anything isn't like it's cool for screenshot purposes. It's not actually like, useful in any way, shape, or form. Like if you can't run calculations at 6 gigahertz, what's the point? Anyway, so we're gonna go up to 5700. Got to pull up our task manager, set affinity. So this is core 8. Man, that is so weird to think about how. Yeah, it's got to be 8. Yeah, because the last core on the chip is core 10, which is like core 6 in. Because the Ryzen Master is freaking numbered from 1 to 6. Windows numbers from 0 to 11, but that includes simultaneous multi-threads. And then hardware info is from 0 to 6. Oh, well, whatever. It's fun. Okay, so and we're going to run. Just going to walk the frequency up again. So 5700, and we did hit the correct core. Right, yeah, because core 4. Everything is running. So we're just going to go straight to 5.8, because, like, that really should work. Because, like, this is a good core, apparently. And 5.8 does, in fact, work. So does 5.825 work? Yep, that doesn't immediately crash, so that's pretty good. 5850 also works. Pretty cool. 5875? No. Yeah, so evidently the core labeling is very, very accurate. At least on this CPU. Again, I haven't tested any other chips for this, so I don't know how reliable this would be across like a very large range of CPUs, but I would imagine it's probably pretty consistently correct that the star core and the silver core are the best cores on the chip. So I guess the last core we got to test, that's probably going to top out somewhere below 5.8. Okay, game mode. Now we're gonna go 5.7. And run. And I did set everything correctly, so we are actually running on the correct core. And now 5.75 works. 5775 also works. So it looks like we've got like 3 cores that are like pretty, like the last 3 cores all seem to be pretty good. 5.8 also works. Let's try 5.825. Oh, that's impressive. Okay, what about 5850? Huh. Oh, and then it reset. Yeah, so we've got like the last 3 cores on this chip are actually quite good by like a couple megahertz more than the other cores. But in the grand scheme of it, it's like, so we've got a few cores that can't do 5.8, a few cores that do 5.85, and then a few cores that do basically 5.8. And that is a like best to worst difference of, and I know I'm really half-assing it because I didn't check 5775 on a bunch of the cores. But 5850 over 5750. Yeah, so the difference between like the best and worst cores is like less than 2% because it's like 1.7% because that's like 5850 divided by 5750. And well, maybe if I did some extra voltage tuning, we could like further push some of the cores maybe, but like at the same voltage, they do seem to be all very, very similar. Now what I'm thinking is, and actually we're going to do CPU Z, and I wonder if this bug is still a thing. So what we're going to do is we're going to go CPU Z, set affinity. We're going to set it to... Which core was the best? Like the second best again? Because I want to... Game mode... Right, so it was core 5, which in Windows would be core 8? Yeah, 8. Because actually this is like from 0 to 5, that would be core 4, so that's core 8 on Windows. So we're going to apply low frequencies across the board, and we're going to go CPU 8, and I'm actually going to clock that core a bit up. So right now, if we look at CPU Z, we can see that we're like below a gigahertz, right? And we can see that across all the cores, and then we go OK. And now it reports all of the cores at the same frequency because CPU Z is stupid. It's also now very laggy. Oh boy. Anyway, let's see if I can get it to read out 6 gigahertz for a little bit. And I guess I could drop the display resolution for this fun little demonstration of silly frequencies. There we go. And I think I'm going to take some extra voltage for this, so we're going to do 1.45. So that's 3.4, and we're just going to go straight to like 5.8. Yay, 5.8. And then we're going to do 5.9. Easy. Oh, and it reset. We're going to give it a bit more voltage. Because we are just sitting idle, so I'm not too concerned about the health of the CPU if it's not actually running anything. Or, well, sitting mostly idle. It is still, like, CPU is still doing, like, polling, and Ryzen Master is probably polling a bunch of things, but that's not as bad as running Cinebench. So, because I want 6 gigahertz. Like, I have now gotten it into my head that I will see a 6 in CPU Z. Anyway, we're just going to set it to CPU Z to show frequency on core 4. So we're not going to do the affinity trick again, but... Yeah, if you're ever wondering about, like, because the thing is, the reason I showed that is because you will often see people show very high frequencies across all cores, and it's like a lot of the time they're just doing affinity to CPU-Z, and that breaks CPU-Z's ability to see the frequency across different cores. Okay, so we're up at 5775. You know what? I'm feeling very brave, so we're going to go to all the way to 1.52, which... This is a completely arbitrary number, which originally originates from the fact that Intel used, like, 1.52 is like a commonly seen, like, high voltage for, like, Intel CPUs that people are like, oh, you shouldn't go above 1.52. The origin of that number is the fact that the Intel 8-bit vid standard ends at 1.52 volts. Like Intel CPUs for the longest time could only describe voltages from I think like 0.6 volts all the way up to 1.52 because there simply wasn't enough numbers to describe more voltages than that. And on newer motherboards, Intel added a 200 millivolt offset to their vid system, so now Intel CPUs can describe voltages as high as 1.72 volts. Neither of those voltages are safe for long-term use as far as I'm concerned, but yeah, like if you're wondering why like sometimes you'll see 1.52 volts seen as like, or like described as like, oh, that's the max voltage for, no, it's just literally the reality of an 8-bit vid value that goes, and actually it isn't from 0.6, I think it's like from like 0.8. Basically, there wasn't enough numbers to describe a higher voltage. So 1.52 was just kind of where the vid table ended for completely arbitrary reasons. 5.9. Okay, I don't think it's going to do 6. Because we are shoving an awful lot of voltage into it at this point, and yeah, it just isn't scaling. I think the only way it would do 6 is if we actually took it sub-ambient at this point. Oh well. I guess we could also try the primary core, but I have a feeling that that might actually be worse, because that one probably has a lot more work to do. So yeah, we are on core 0 by default, so we're going to go game mode again. Drop that. And we're going to go down to 1.5. It's also possible, like, even if you're not actually running anything, you're still able to cause voltage rollover. So that's worth keeping in mind. So that's 5925, 595, and no. Moving the mouse is too much at this point. Yeah, so I guess this chip isn't... I don't think this chip is going to do 6 gigahertz. And I don't feel comfortable raising the voltage any higher than this. I would prefer having the CPU working, because it does have a very good memory controller, even if the cores don't necessarily seem to be that great. Yeah, like I do like having like, I mean, if we could degrade the cores without affecting the memory controller, but it's like, I'd prefer to have the CPU in like good condition rather than not good condition. So yeah, that'll be the end of this video. I wonder, I kind of want to try this with my 7950X now, because the 7950Xs get better CCDs than like a 7600X does. So I'm kind of wondering, like, would the 7950X be able to validate like over 6 gigahertz if you know, did this per core thing? Probably could. Almost certainly could. So yeah. Anyway, that's it for the video. So thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the HOC Teespring store where you can pick up shirts, hoodies, posters, you know, the usual YouTuber merch. And I've also got a Bandcamp, and there's links to all of that down in the description. So if you'd like to support the channel, if you can use those, it would be much appreciated. And yeah, that's it. So thanks for watching, and goodbye.